First, I'm going to talk about FME Server meets the challenge of real time. And so real time is one of the data types in FME that we're pretty excited about in FME Server. And so, real time data, there's more and more of it all the time coming from sensors. So here we just have, some aerial sensors, satellite sensors. We have, sensors on firefighters or personnel, traffic cameras, of course, sensors are a lot, lightning sensors, we're going to talk a little bit about that. And of course, social media just generates a ton of real-time data. So, and not to mention all the apps that are out there. We often hear about, the Internet of Things, and so we're going to talk about that as well. So when you're working with real-time data, you need to be aware of two things. One is that how much data is coming at you. Obviously, data volume is a key thing when you're designing any real-time system. The second thing is data velocity. How fast are you receiving this real-time data? Is it a user sitting at a screen clicking a button every once in a while? Is it a system, maybe a flood gauge monitor on a river that only sends you periodic updates? Unless there's emergency, then it will send it more. But still, the time that it's sending data is measured, in once a minute, once a second, things like that. Okay. Or is it a real high-speed stream in which you're getting thousands of requests a minute or second? So that's really what you need to deal with. With FME Server, we can handle both. We've built two separate approaches to real-time data. The first one we call on-demand real-time, and you can think of this as a notification-based technology. And Aaron, in fact, used that with his drag-and-drop capability, where with his whole ability to drop a file in and then have something done. Also, that email where you would send in the email for the CAD. That was another example of notification-based technology. So email is not a real-time data stream, and so that's another great example of real-time things. Generally, you can think of this notification-based. Whenever there's a person generating the data, often you can think of that. That's a good key to notification-based. If it's coming from a server or a piece of hardware or a device, then you have to look a little bit closer to understand the characteristics. The second type of approach is a continuous real-time, and this one is for high data velocity and low to high data volume. And this one's dedicated engine technology, so we're going to go after both of those here. Okay, so at the end of the day, what are we trying to do? The story with real-time data is the same with FME as any other kind of data. FME consumes all this data, can do some operations on the data, run some rules, do some analytics on it, and then help you make decisions by pushing the relevant data out to whatever system you want to use for visualization or other purposes. So at the end of the day, that's what it's all about. When it comes to event-based, here are just some of the things. So you have email. We have a REST API for arbitrary. A scheduler, strictly speaking, is an event-based thing, but at this point it's not tied into our topics. Maybe it should. A couple of Amazon services. So you see what we're doing with FME when it comes to event-based, again, is tying into as many different systems as possible so that you're able to leverage the real-time capabilities of FME regardless of where the data is coming from. So it's very similar to what we've done with formats. Over time, we've added more and more formats to FME so that you can get the power of FME. Same thing here. We're adding more and more of these connection types to FME Server so that, again, you can easily plug FME Server into whatever data flows that you want. The other point is that the connectors here don't define that these are event-based. In fact, you're going to see some of these both here and also on the dedicated engine technology. So, of course, FME can also generate events and push these out to other systems, and here you see some of them here. FTP, Amazon S3, you can have it copy files out there, output REST API, of course, mobile devices, email, it can send email, again, as Aaron showed, and then WebSockets. Aaron also showed that. When a workspace is run, the output is streamed back to a web browser. So that was another example there. And here's the ones on the output side that FME is able to push data to. Okay, so a good example here is our friend in Australia who built a Barrett, who built a new app. Oh, come on, internet. Oh, lovely. Don't you love it when you're using Windows? So anyway, so it's hanging on me. Lovely. Okay, so okay, that's interesting. Okay, we'll try that again. Okay. So anyway, what he did here is as you've heard, and so what they've done is he built a mobile app to help people. So what they can do now is they use this mobile app. They go out in the field and they touch locate a spot where they want to build a building, and then the request goes back to FME Server that runs both terrain analysis and vegetation analysis to determine if this is actually a good place to put a building. Now, in the old days, of course, what they would have to do is it was very manual. They'd have to use more traditional approaches with surveying and things like that. Very time-consuming, very expensive, and so that's this is obviously revolutionary when it comes to deciding where to build buildings, and ultimately it's going to save lives. But it's also a great example of a way to use FME, and this is clearly an event-based process. People go out in the field, they send a request. The request takes about 3 seconds to come back, and so you can, you don't need a dedicated engine or anything like that. Okay, so let's see if this is going to work here. It looks like my internet is having a bit issues here. So we're going to, this is just a quick one. Oh, you've got to be kidding me. So that's really not good. I kind of need the internet here, so I'm not sure what's going on. So let's go back over here. I've never seen this before. Okay, well, this is going to put a damper on things for sure, because so we'll go right to the next one, and maybe things will start working. Not sure what's going on. Anyway, I am broadcasting, but I can't actually hit any internet. So the second-based approach is a high-velocity data streaming approach. So in this case, the whole notification process of FME is not going to be able to handle it. And so what we have is we have this dedicated engine approach. And in this approach, you can see an FME server here with multiple engines. A single engine is dedicated to processing the data stream. And you can see the different types we support here: WebSocket, TCP/IP, TweetStreamer, JMS, and so on. And so a good example of this is Pelmorex. So what Pelmorex did is they have a weather network with lightning strikes, and they get up to 8,000 strikes a minute. So there's a dedicated engine again with a TCP/IP receiver. Updates are sent to Google Earth every 20 to 30 minutes based on some rules that are run to determine if a lightning strike is relevant. If it's not relevant, then Google Earth isn't notified. So like one lightning strike in a remote area is not relevant, but if you get a whole bunch of lightning strikes in a single area, then that is. So that's 8,000 a minute. They tested this with something called Stormageddon, and with up to 50,000 lightning strikes a second, and the FME engine was able to go on, so to carry on and still process all that. So that's a great margin of errors there, safety. They also were able to send, FME runs its rules and sends data down to the Java messaging service and also to mobile devices. So so there we go. That's what they look like. Now I'm going to click on this again just because I'm a brave individual, and oh, it's working now. Okay, I want somebody to explain that to me, but whatever. The internet's now working. Oh, and my camera's on. So all these sorts of things are all good. My hair looks great, I'm sure. So here we go. So the first one is just showing you, this is real-time data feeds of boats and things in California. Okay, so that's kind of interesting. You can see the ships moving around, the buses, and you'll see the planes moving around. So that's that one there. Okay, the second one though is my favorite, and this one shows you just how well this whole thing scales. So this one is from a blog that Stuart did, where he built a flow showing all the Twitter feeds coming into FME Server. So if I click down here, this goes to FMEpedia, where you can actually download this example if you want. And this shows you, this is like live, all the Twitter feeds going on in the world. So you can zoom into anywhere you want and then see what's going on. So so again, clearly dedicated engine technology here, because definitely you can't you couldn't have all these being to the notification or event-based approach. So there we go. Okay, so that's that one. And again, there's two things to remember when you're working with real-time data. The first is data velocity and data volume. Those are the things that define how you're going to do it. Are you going to be able to use the on-demand approach when you have low data velocity and each event generation or each topic post has a little bit of data, or are you going to have to go to a continuous real-time approach where the data velocity coming at you is fast and furious? And the big news is FME Server has been architected to meet the needs of both.